Hey everyone, this is going to be your review for chapters 10 and 12, but we're going to be doing only the chapter 10 review today, and we'll do the chapter 12 when we all get back. So in this, we're going to be going over the information from chapter 10, and I'm going to also give you a lot of opportunities to do these problems. And then what I'd like you to do is, instead of just copying it down, is I want you to attempt the problem. Pause it and when indicated to pause, and then come back after you've attempted the problem. If you got it wrong, you can always go back and change it, but this is your opportunity one last time to get this right, in case if you're having any trouble with this. So again, here's the chapter 10 review, and we're going to go ahead and get going with this. So some of the information will be given to you on the exam. Just like on the chapter quiz for chapter 10, you had Avogadro's number. That number is 6.02 times 10 to the 23rd. And this is the number of atoms or molecules. We can always also say or ions. We can also say or the number of particles. So we had these mole bars in class, and each of them was approximately a mole. Each of them had 6.02 times 10 to the 23rd metal atoms in those metal bars. And what was interesting is that 1 mole, when you have 6.02 times 10 to the 23rd, this is also equal to the atomic mass. So, for example, we had zinc. The atomic mass of zinc is 65.4. And we found out that when we had 1 mole, when we weighed that bar, it was about 65.4 grams. So this number of molecules gives the metals their weight. And each material is going to weigh differently, 1 mole, because they have different masses because of the number of protons and neutrons in their nucleus. So we're going to give you your first opportunity to practice. 1 mole is equal to how many grams of a substance? This is called the molar mass. And remember, the molar mass is also the sum of the atomic masses. So we're going to be calculating the molar mass of magnesium chloride. I'd like you to do that right now by listing the atoms present, indicating the number of atoms that we have of each element, multiply them by their atomic masses, and then add those all together. So I'd like you to do that right now and pause. Okay, so hopefully you've come back and you've completed that. In case if you didn't or need some help, we have to first list my magnesium, and then we list the chlorine or the chloride ion. You then look at the subscripts to determine how many of each atom that you have. I have 1 magnesium, and I have 2 chlorines. I've given you the atomic masses based upon the periodic table. So magnesium weighs 24.3 grams. The chlorine or the chloride ion is going to weigh 35.5 grams. When I multiply these, 24.3 grams of my material and 1 mole of substance will be of the magnesium. And I take the 2 times the 35.5. This will give me 71.0. And we have to add these together. It's the sum of the atomic masses. So I have a magnesium plus a chlorine plus a chlorine. When I add those together, you should get 95.3 grams. And if you have 95.3 grams of magnesium chloride, you therefore have 1 mole. So 1 mole equals how many grams of a substance? We're going to use magnesium chloride as an example. This is the molar mass. 1 mole of magnesium chloride will weigh 95.3 grams. 1 mole of any gas has what volume? This was the mole box that we did in class as well. This number is going to be 22.4 liters. This is a number you do not need to memorize. It will be on the exam for you. You just have to know how to use it. Remember, when you're using the atomic masses, you should use it to the nearest tenth for any element. For example, sulfur is listed as 32.065. However, we need to use this to the tenths. So we would round this. We would use this number here to round up. This would be then 32.1 grams. So this will be, again, sulfur. Again, the atomic symbol is going to be S for the sulfur. And it will weigh 32.1 grams. Not 32 grams, not 32.0 grams, but 32.1 grams. So if you're given these values on the test, make sure you're using to the tenths. 24.3, 35.5. Again, also when you're calculating the molar masses, make sure that you're multiplying by the number of each atom as well. So convert from grams to liters to grams to molecules to liters to moles. This is mole city. So to remind you guys, you have mole city that's sitting in the middle right here, and you have your liters, and you have your mass over here, and you have your particles over here. And when I say particles, I'm saying you either have atoms, molecules, or ions as well. So we've done each of these separately, converting particles to moles or moles to particles. This is going to be using Avogadro's number, the 6.02 times 10 to the 23rd. So if you're converting from particles to moles or moles to particles, you're going to be using 6.02 times 10 to the 23rd. We also converted from moles to liters and liters to moles. We'll have many examples on this on the opposite page. And again, we're going to be using 22.4 liters. And the last one is converting from grams to moles or moles to grams, and that's what we did up here. This is the molar mass. Okay, so this is the molar mass of a substance. Molar mass, which you will have to then determine based upon the mass of each element and the subscripts indicating the number of atoms in that compound. So going again to moles is one step. We did this. This is another step, and this is another step. And we're going to go through some examples, converting from mass to liters, or liters to particles, or particles to mass, or vice versa. And you first have to convert and pass through mole city in order to do this. So if you can go to the other page, next page, we'll have some more examples for us. So what I've done for you on this is I have also shown you that we have problem number 1, problem number 2, problem number 3, etc. going through here. There are going to be 9 problems on this test, and each of these types of problems are going to have the same order as you will see on the test. So I'm not going to mix things up. So problem number 1 is going to be converting from grams to moles, or it's going to be converting from moles to grams. Now, how many steps is this going to be? If you go here, you're going from grams to moles or moles to grams, then you are going to be doing just one step here. So I'm going to give you 2 opportunities to practice so that you have each possible scenario, because there's 2 possible scenarios that you can have, again, grams to moles or moles to grams. So the first question is going to be, how many moles? If I have 18.0 grams of magnesium, the question is, how many moles do you have? So you need to find the molar mass, which is actually on the first page, which you can take a look at. And I'd like you to solve for this problem right now by multiplying by the molar mass. Remember, you're trying to cancel grams, so that will be in your denominator, and you're converting into moles, which is going to be in your numerator. 1 mole of this weighs how much? It's on the other side of the page. So I'd like you to go ahead and go through the calculations of this and see if you get this one right. Please pause it right now and attempt this problem. Okay, hopefully you've come back and you've looked on the other side and you found magnesium weighs 24.3 grams. So we need to multiply this by the molar mass, and we're going to cancel my grams. So my grams is going to be in the denominator, and I'm converting into moles. Again, this is just a 1-step problem. 1 mole of the substance magnesium weighs 24.3 grams. You'll notice that the grams are going to cancel, and you're going to be left with moles of magnesium. If you divide 18.0 by 24.3, you will get 0.741 moles of magnesium. So again, when going from grams to moles or moles to grams, we're multiplying by this factor here, which is also called the molar mass. 1 mole of that substance weighs how many grams? Okay, this one's going to be a little bit more tricky. The question is going to be, how many grams if you have 2.30 moles of chlorine? So do the same thing, multiply the molar mass of chlorine, note that this is Cl2, not just Cl, and see if you can get this answer correct. Please go ahead and attempt this problem now. Okay, hopefully you've come back and you've solved this, and we need to multiply by, again, the molar mass, but not the molar mass of the magnesium, it's going to be the molar mass of the chlorine. So I want to cancel, my units are moles, so I'm going to cancel with my moles of chlorine. And 1 mole of chlorine weighs how many grams? So I have chlorine. I'm going to list the chlorine right here. So I have chlorine, and I have 2 of them, and each of the chlorines weighs 35.5. That will give me a mass of 71.0 grams. So each chlorine weighs 35.5. 1 mole will weigh 2 times of that because it's Cl2. So I'll then put my 71.0 grams up on the top right here. My moles cancel and my moles cancel. And now I'm going to take this and multiply it by this. 2.3 times 71. This will give me 163 grams of chlorine. So that's problem number 1. It's a 1-stepper, grams to moles or moles to grams. And you will find out which of these it's going to be. And again, you are using simply a 1-step problem using the molar mass. Now, convert from molecules to moles and moles to molecules, or convert from moles to liters and liters to moles. So, first question is going to be, how many liters? If I have 2.67 times 10 to the 24th molecules of H2. So I have molecules, and I'm trying to travel to liters, and this is going to be a two-step problem, and I first must pass through a mole city. So I'm going from molecules, or particles, over here, and I want to go to liters. So again, I need to pass through this, which is mole city. So I first need to convert to moles, then after moles, then I need to convert to liters. So I'll be using Avogadro's number first, and then I'll be using the molar volume, which is 22.4. I'll be using that second. So what I'd like you to do is to go ahead and to attempt this problem. It's two steps. You're going to cancel the molecules by using Avogadro's number equal to 1 mole, and then you're going to cancel your moles and convert it into liters using the molar volume of 22.4. Please go ahead and attempt this problem and pause the video now. Okay, so we're going to go ahead and continue this and solve for this. So again, I always want to start by canceling what I have. I have molecules, so I'm going to cancel my molecules and convert them into moles. 1 mole is 6.02 times 10 to the 23rd molecules. You'll notice the molecules cancel, and so therefore I've converted my molecules into moles. But I want to get to liters, so the next step is going to be 1 mole is equal to 22.4 liters. And the moles cancel, and the moles cancel. Now, this is a tricky problem on your calculator, and what you need to do is make sure that you're using parentheses on your calculator. Otherwise, it's going to put the 10 to the 23rd in the very, very top. So let's try to figure out what my answer should be. Do I have more or less than a mole? I have more. I have roughly maybe about 10 times more, close to being 10 times more because I have a power of 10 more. So let's say I have roughly 10 moles, and I'm multiplying it by 22.4. My answer should be around 200. However, if you're getting an answer of something to the power of the 48 or 49, then you know you've done something very, very wrong. So if you multiply these two and divide by this on your calculator, remember, use parentheses, or you can divide by 6.02 and divide by 10 to the 23rd, and your answer on your calculator should be 99.3 liters of H2. Next question is going to be, how many grams of chlorine if I have 52.0 liters of chlorine? So I'm going from liters to grams, and you have to have this kind of envision in your head. I'm going from liters up here to grams, so I have to pass through mole city. It's going to take me one step. It's going to be a two-step problem doing this. So what I'd like you to do is first convert this into moles by using the molar volume of 22.4 liters equal to 1 mole. And then you have 1 mole is going to be equal to how many grams? 1 mole of chlorine. So remember, we need the molar mass for that step. And so we need the molar mass of chlorine. We've already done this though, if you remember. We have 2 chlorines, each weighing 35.5. What I'd like you to do is try to calculate the number of grams. I'd like you to pause the video and attempt this problem now. Okay, hopefully you finished that, and we're going to check to see if you've got it right. So again, my first step is always to cancel what I've been given, and I want to cancel my liters. And I'm going to be converting into moles, going through Mole City. 1 mole, this is chlorine gas, 1 mole of any gas is going to be 22.4 liters. My liters will cancel, and my liters will cancel. I've now converted this into moles. So now, do I have more or less than a mole? I have roughly about 2 moles. This is almost double of this. It's a little bit more than double, okay? Now let's go ahead and calculate this over here. I want to cancel my moles with moles and convert to grams. 1 mole of material will weigh how many grams? This is chlorine, so we're going to be bringing this number down here, 71.0. So I'm going to have roughly double of 71.0. The moles cancel, the moles cancel. This here, again, to remind you guys, this is the molar volume. And this simply here is going to be the molar mass. Here again is my molar volume. This is Avogadro's number. So when I multiply these two and divide by what's on the bottom here, you should get on your calculators 165 grams of chlorine gas. So now, percent composition is the percent of each molecule by mass in grams. If you remember percent, a percent is a measurement of the part of something divided by the whole. We're going to use water as an example, and we'll go through this, and then I'm going to give you an example to try to solve down below here, using the same principles. So here's water, H2O. What is the percent by mass of hydrogen, and what is the percent of mass for oxygen? Meaning, what does this whole molecule weigh, and what does the hydrogen, the part of the hydrogen, weigh compared to the whole? What does the oxygen, which is the other part, weigh compared to the whole? So first we need to calculate the molar mass of water. So we have to have a hydrogen and oxygen. I have 2 hydrogens, and I have 1 oxygen. The molar masses of these substances will be given to you on the test. Make sure that you're using them to the tenths. Hydrogen weighs 1.0, oxygen weighs 16.0. Each hydrogen weighs 1. I have 2 of them, so the total mass of hydrogen is going to be 2.0, and this weighs 16.0. So water will weigh 18.0 grams. So here's my part. Here's the other part. And here's the whole. When you add the 2 parts, you get the whole. So what we now have to do is take the part and divide it by the whole. Hydrogen weighs 2 grams of 18 grams. So you take 2.0 divided by 18.0, multiply this by 100%, and this will give you, on your calculator, 11.1%. Try it and see. Just to confirm, so hopefully you've done this on your calculator, and you'll get 11.1% of hydrogen. What's the percent that is oxygen? So we take the part of oxygen, so oxygen weighs 16 of my 18 parts, 16.0 divided by 18.0, and multiply that by 100. So take your calculator, 16 divided by 18, multiply by 100, your calculator should read 88.9% is oxygen by mass. And again, if you add those together, they should give you 100%. This is the part that hydrogen weighs, this is the part that oxygen weighs. So what I'd like you to do now is do the same problem, but now using magnesium chloride, MgCl2. I'd like you to calculate what is the percent composition of the magnesium, what is the percent composition of the chlorine. Remember, it's MgCl2. Please go ahead and attempt this problem and pause your videos now. Okay, hopefully you finished this problem. We're going to go ahead and now check this. We have magnesium and we have chlorine as my two elements. How many magnesiums do I have? I have 1. How many chlorines do I have? I have 2. I now multiply by the mass of each atom. Each atom will weigh 24.3 for magnesium. Chlorine will weigh 35.5. Okay, so again, this is going to be equal to 24.3. This is going to be equal to 71.0. And again, we should get 95.3 grams. This is the part, here's the part, here's the whole. So I'm going to do my magnesium first, and I will take 24.3, which is the part that's magnesium, divide it by my whole, which is 95.3, and multiply this by 100%. And you should have gotten 25.5% is going to be magnesium. The other part is going to be chlorine. The mass of chlorine, because we have 2 of them, is 71.0. Divide it by the mass of the whole molecule and multiply that by 100%. This should give you on your calculator 74.5%. So 25.5% is magnesium, 74.5 is chlorine. Next one is going to be the percent composition. Or it's close to percent composition. If given a sample of known mass, calculate the grams of each element of the compound by calculating the percent composition and multiplying by the mass of the compound that was given. Okay, so we already know by this that my sample weighs 25.5% magnesium and 74.5% chlorine. Okay, now let's assume that I have, let's say I was given a sample that's 47.0 grams. The mass of the compound given is going to be 47.0 grams of magnesium chloride. Okay, question is, how much of magnesium do I have and how much chlorine do I have? So what I'm going to do is you're going to multiply this sample by the percentage that you have right here. So again, you're going to be converting this into a decimal, converting this into a decimal, and multiplying it by this right here. So here's my sample. Let's say I've been giving it to you, you're holding it in your hand, and I have 47.0 grams. How much does the magnesium weigh, and how much does the chlorine weigh? Well, we've already calculated the percentages, percent composition from the previous example, and I'd like you to now calculate how many grams do I have of magnesium, and how many grams do I have of chlorine? We're starting with this and multiplying it by the percentages from the other page. Please go ahead and do that now. Okay, so I'm starting off with my 47.0 gram sample, and I'm multiplying that by 25.5% as a decimal will be 0.255. And if you multiply that, you should get 12.0 grams of magnesium. And when you take a look at the chlorine, we're starting off with my 47.0 gram sample, multiplying this by, my percentage is 74.5, so I multiply by 0.745, and this should give you 35.0 grams of chlorine. And again, when you add those together, you should get back to the full mass of your sample. So this concludes the review. The video is about 30 minutes long, but this also gave you some time to work on these at home, and I hope it didn't go too much over the 50 minutes allotted for this class time. If we have questions, please email me. Please ask me. When we come back, we're going to continue. This is looking at Chapter 12. We finished Chapter 10, which we've all done before anyone was quarantined. So hopefully this looks familiar to you, and hopefully this is something that you feel comfortable with. But if you're not and you're still struggling, please talk to somebody in the class, or come see me, or email me as well. We'll see you guys very soon on Monday after Thanksgiving break.